everybody, and welcome back to another fun and exciting intermediate math class. Today we are going to be talking about actually one of my favorite subjects in math, and we're going to be talking about something very useful today, something that sometimes students go, when am I ever going to use this, right? You've heard people say that. Well, let me tell you when you're going to use this. You're going to use this all the time in life. You're going to use this at the gas station. You're going to use this at the grocery store. You're going to use this when you're cooking. You're going to do this when you are working in construction, when you are doing really anything. I mean, it's all over the place. It's very, very useful. So pay attention today. It's a very useful lesson, something that you need to learn. All right, so here we go. Let's jump into it. If you have your books, go ahead and open up to page number 55. Page 55 is where you will find today's lesson, 1.11. Today's lesson is 1.11. So go ahead and open up there, page 55. Today we're going to be talking about fraction decimal equivalence. What does that mean? Well, a lot of times in math, we don't have a whole number, we have a part of a number. We've already been dealing with fractions, and today what we're going to do is we're going to talk about how, look, it says here, decimals and fractions are different ways to represent parts of numbers. You can represent a part of a number as a fraction or a decimal. It's the same part of the number, but just a different way to represent it. So in other words, you could take a fraction like 1/2, and you could say, okay, I have 1/2 of something, or you could convert that to a decimal, and you could say I have 0.5 of something. So having 0.5 of something is the same as having 1/2 of something. You're just saying it in a different way. There's a couple different types of decimals. One of those types of decimals is here, terminating decimal. A terminating decimal is a fraction that divides out evenly. In other words, let's take this example down here, 1/4. When we divide that, remember how I showed you to knock this over and divide it. So you might be thinking, like, 4 doesn't go into 1, so when we knock it over, we end up with what? We end up with 4 goes into 1. And you might say, that doesn't work. Come on, I don't even know what you're doing. Well, what you do in this case is you add a decimal, and then you start adding zeros. How many zeros do you need to add? I don't know. You need to add as many as you need. Okay, you just keep doing the division and keep adding the zeros until you're done, until it comes out evenly, or we get what's called a repeating decimal. We'll talk about that in just a second. So one thing in division is that I'm going to take my decimal and I'm going to put it right up here, right? So I just line it right up. And then I say 4 goes into 10 how many times? 4 goes into 10 2 times. So that goes 8, subtract, and I'm going to get 2. Bring down my next 0 and I get 20. 4 goes into 20 5 times. 5 times 4 is 20, and there's my 0. As soon as it zeroes out, I'm done. So in other words, the answer to this, in other words, 1/4 is equal to, right? So let's put an equal sign there. 1/4 equals 0.25. They are the same thing. If I say I have 1/4 of a pizza, I could also say I have 0.25 of a pizza. Okay? Now, the next one, so that's a terminating decimal. You could see that decimal ended, right? That stopped. 0.25, it zeroed out. We didn't keep going because there was nothing else to do. Notice here with repeating decimal, notice what happens. A fraction that represents a pattern when dividing out. So what's going to go on here? Let's go ahead and do this one. Let's knock it over. So 3 goes into 1. Remember, we have to add our decimals here. So point with some decimals. Let's kind of extend that. And we're going to say 3 goes into 10. Put our decimal up here 3 times. 9, 1, bring the 0 down, 0. 3 goes into 10 3 times. 9, 1, add another 0, bring it down. Notice what's happening here is there's a pattern that's formed. What's happening is we just continue to get 3s. 3, 3, 3, 3, 3, 3. That is look, it's a pattern. has started. It repeats a pattern when you do it. So this is called a repeating decimal, 0.33333. Now, so 1/3 is actually equal to 0.33333. Now, we don't really write it like that. We can do a couple things here. We can round it off, so we could say 0.3 and just say we rounded it off. If we do that, we actually would have to say 1/3 is approximately equal to. See how I kind of made like a squiggly line on the equal sign? That means it's approximately equal to. In other words, we rounded it off. The other way is I could say that 1/3 is equal to 0.3 with a line over top of the 3. When I put this line over the top of the 3, it means that it repeats. It keeps going. That's what that line over the 3 means. So we don't have to put approximate on this one because it does repeat. And we're saying that it repeats by using that line over top of the 3. So there's terminating decimals. Okay, that's the one that stops. And then there's a repeating decimal. That's the one that continues on. There's another type of a decimal called an irrational number. Well, something that's irrational doesn't make any sense. So rational makes sense to people. Irrational makes no sense. These are numbers that never stop. For instance, pi is irrational. When you divide out pi, it never stops, 3.1415, and it just keeps going and going and going. They actually have supercomputers that all they do is try to divide out pi, and they're out to like the billion, cajillion, bazillion. That's not really a number, but if it was, that's what they would be out to because they keep dividing it out and it just keeps kicking out numbers and numbers and numbers because pi is irrational. Pi never stops. Pi never repeats. Pi never terminates. Okay? So irrational numbers never stop. They never end. Okay? So that's 3 different types of decimals. Terminating, they stop. Repeating, they repeat a pattern, and then irrational, they never stop and they never repeat. All right, let's look at some of these. This is the part of the lesson that I love. I absolutely love this part. Why? Because it is so useful in life. If somebody says, I have 1/2 of a pizza, that means that they have 0.5 or 0.50. They kind of added that other 0. You don't need that 0, by the way, right? So 0.5 or 0.50. You can write it either way. If somebody says, I have 1/3, then they have 0.3. And we remember from what we just did that that would be repeating. So we would need a line over that, or we could just round it off, either one. The next one is 2/3, and that's 0.6. And here's the beauty of this. Now, we could figure this out if we actually took, right, if we actually took our calculator out or if we actually divided it out. We would find out that it gives us that. But here's what you need to do. And here's the part of the lesson that I love. You can just memorize all of these that go with those, and they will work every time. If somebody says I have 2/5 of something, you know they have 0.4. Okay, because if you divide it out, so 2/5, you knock it over, and you do 5 goes into 2, or 20, it goes 0.4, right? 0.4, because that would give you 20. So that's the way that you do those, but you don't even need to divide them out because you just memorize 2/5 equals 0.4. And then you would come over here and you'd memorize this side. Now, you might say, that's not worth it. I'm not going to spend the time to memorize it. It is worth it. It is. You will use these all of the time. All of the time. Okay? So figure them out, learn them, understand them, and that way you don't have to break out your calculator. That way you don't have to do all the math that it takes to get the solution to these. Okay? Highly recommend this list that's right here. It is also in your book on page 56. Let me write that. Page 56. Memorize the list of fraction decimal equivalents on page 56. You will not be sorry. You will be so happy. You will thank me later. Okay? Memorize those. All right, one more thing in this lesson, and then we'll be done, is we're going to talk real quick about unit price. This is on page 57 in your book, unit price. So here's what we want to do with unit price. when you go to the grocery store, right, and you go to buy some peanut butter, for example, there's different sizes of peanut butter. So maybe you wonder, okay, which one is the better price? Maybe you've noticed in the store there's like a little tag on the shelf where the peanut butter is. A lot of times the stores, in fact, in some states, maybe all states now, it's the law that the store displays both the price and the unit price. What does that mean? Notice it says right here, the unit price is the cost of an item based on a unit of measurement. So, for example, peanut butter comes in ounces, 16 ounces, 12 ounces, 24 ounces, whatever. And so you would find out how much am I paying per ounce. And that would tell you which one is the better price. Should I buy, the name brand peanut butter? Should I buy the off-brand peanut butter? Should I buy the big jar of peanut butter? Should I buy the small jar of peanut butter? And when you understand unit price, you'll understand which one is the best price. Notice I wrote, this is a great way to compare prices and find the best value. This is us using our fraction decimal equivalents to shop and to find good prices. So all we want to do, and this is really kind of it's like a one-stepper in a way. All we want to do is we want to take the price and we want to divide it by the number of ounces. So we're just going to take, basically it's like a fraction. So we would put the 756 on top divided by the 17. And that's all we want to do. So we're just going to have a division problem. Just change the color so you can see it. So 17 into 756. And so we'll just find out what this costs per ounce. So you'd say 17 goes into 75. We're going to have to do some estimation. I might try 4. It might not go 4. I'm just going to guess 4. Maybe it'll go less. Maybe it'll go more. But we'll just see. So 4 times 7 is going to give us 28. And then 4 times 1 is 4, 5, 6, 68. I think we got the right one. So we'll go ahead and subtract here. We're going to need to borrow. So 8, 5, that would be 7. So notice when we compare, 7 is less than 17, so we're doing good. Now we're going to come over here and we're going to bring down our 6, and we're going to get to 76. Well, we were just at 75, and it went 4 times, so we're going to try 4 again. And we already know that that goes 68, okay? And then we'll subtract there, and we're going to get 8 this time. Now, notice it says find the unit price per ounce to the nearest cent. Okay, you might be thinking, okay, if this is dollars, I'm already to the nearest cent. Okay, but if we're rounding off to the nearest cent, we have to go and look at his next door neighbor, right? Remember, we can't just say, oh, it's 0.44. What if that next number is a 5 or greater? It's going to make that 44 go up to a 45 because we rounded off, okay? So we need to do one more. So we need to add a 0, bring it down, and we get 80. Notice we basically have the same thing again. We're really close. We're at 75, 76. Now we're at 80. We can probably try a 4 again, and we get 68 again, and then we get 12. Notice that 12 is smaller than 17, so the answer would be 0.444, but we're rounding to the nearest cent, so we're going to look at the next door neighbor. It's 4 or less, so we leave it the same. The answer to the problem would be 44 cents. The unit price per ounce. Okay, so we're buying olive oil, and it's per ounce because we had a 17-ounce bottle, right? So it's 44 cents per ounce. Now, how do I use that? Okay, so I'm in the store, and how do I use that? So I go and I look at the other one next to it, and I do the same thing. So I have one bottle, 44 cents. I do the math on the next bottle, because maybe the other bottle is smaller, or it's a different brand or something. It's a different price. and I figure it out, maybe it's a 10-ounce bottle, and I find out that the other bottle costs, let's say that it costs, the other one costs 42 cents per ounce. Which one am I going to buy? Well, I'm probably going to buy the 42 cents per ounce. Why? Because it was cheaper, right? Makes sense. I don't want to spend more money. I want to spend less money. I worked hard for that money, so I want to spend less. So I would probably buy the one that comes out cheaper per ounce, if that makes sense. Even though the final price might be a little bit bigger, because I'm getting more ounces, I'm saving money. So sometimes when your mom buys that big, huge bottle of laundry detergent or oil or whatever, she's doing that because she wants to save money, and it's cheaper to buy the big size versus the small size. And that's all based on unit price. Okay? All right, well, that's all I have for you in the lesson. Hopefully you learned something there. Make sure that you memorize those things, those fraction decimal equivalents. Very, very important in life. You're going to use these all the time, I promise. Okay? I wouldn't lead you astray. I promise you, you will use those. Okay? All right, well, if you missed anything, scroll it back, watch it again. Okay? That's all I've got for you. Have a good one. Bye-bye.